minus the bottom curve. Well, what if the upper bound, okay. All right, so what if your upper curve, and what if the thing that you're intersecting it with is actually below the x-axis already? Okay, so what if they're not both above the x-axis? What if one is above and one is below? And we want to find the area between those. Okay, so now the area is a lot bigger. It doesn't change how you do the problem. You're still going to find the new intersection points of C and D. You're still going to set up your integral going from C to D. And the upper boundary is still formed by x minus the lower boundary is still formed by g, even though it's below the x-axis. And so what that does, there's no change in the format, so you don't have to worry about, well, am I below, but it's okay because the negative of the subtraction takes care of the negative area. So it's like subtracting something that's already negative, which ends up adding the two things together. So regardless of where they fall, either above or below the x-axis, the setup of that is exactly the same. But what if they cross each other multiple times? Okay, so suppose that you have this one, and then the thing that was coming through crossed it like that. All right, well, the area between them now is going to be that little region, and then a smaller region, and then that. So you're going to have to set this up in different intervals because they have different intersection points. So here's your C, there's your D. Now you have an intersection point E and an intersection point F. So as you set up the area for that, you'll have the first integral, which is going to go of the interval of C to D. And in that case, the upper boundary is formed by x, and the lower boundary is formed by that g parabola, dx. Then you'll add to it a second integral, which starts at D and goes to E, but you're going to switch the order because the upper boundary of that little center piece, the upper boundary is now the piece of the parabola, so now g of x would come first, minus f of x dx. Then you'd have 1/3 integral from E to F, and then it switches back. And now the F term, F function is the lead function or the upper boundary, and the g of x term comes second. So you're going to have a mixture of problems that are going to be set up without your calculator. These problems need to have nice functions and nice intersection points. And they will. If you don't have your calculator, then everything will come out to be a nice integer or rational number. If you do have access to your calculator, you're going to get more complex functions whose intersections are at non-rational numbers, at decimals. So I'm going to show you how to use your calculator to do that. Question, Oliver? Okay. So let's do some actual problems. We're going to do one without our calculator, where it's all going to work out nicely. And then we're going to do one with our calculator, where the calculator will make it work out nicely for us so that we couldn't do it on our own. All right, so without our calculator. So this is called analytical. That would mean don't use your calculator. So find the area between the following functions. Y equals x squared minus 3x plus 2. And y equals negative x squared plus 4x plus 2. And we're going to do this totally without our calculator and just with what we know about functions. Well, both of these have the same shape. What are they? Two parabolas. Okay, both of them end with a plus 2. Their plus c's are the same, so what does that mean? Okay, they both have the same y-intercept, so they're both crossing with the same y-intercept. All right, so our y-axis, we'll mark off 2, and maybe I'll put 0 right here. I don't need an x-axis. One of the parabolas is positive. The first one is positive because it's a positive x squared, which means it's facing up, it's concave up. The other parabola is negative, and so it's concave down. So we'll have one parabola that's going like this, and your drawings don't have to be perfect. Okay, and then your second parabola starts at that same place because they both share a y-intercept. Okay, so something like that. It does not have to be perfect. You just need to know which one is the upper one and which one is the lower. So I'm going to be finding the area between these two. So before I can set that up, I need to know what my intersection points are. So this one, I know what the x value is. I know the y value is 2, but what's the x value there? 0. And so I need to find this other one. Okay, so this one is 0. I need to find the other one. So how do I mathematically, without using my calculator, find that second intersection point? Yeah, set the two problems equal to each other. All right, so we'll come and do a little algebra. So we'll take x squared minus 3x plus 2, set that equal to negative x squared plus 4x plus 2. And we want to do the algebra on that. Okay, lots of times it's not the calculus that people get tripped up on, it's the basic algebra and factoring. So we want to set this equal to 0, so we'll add x squared to both sides. So it'll give me 2x squared. I'll subtract 4x, that will give me minus 7x. And then I subtract 2, which gives me equal to 0. So I have a pretty simple algebraic expression to solve 2x squared minus 7x equals 0. So I'll factor out the x that they have in common, leaving me with 2x minus 7. And so then I have the results of the first x is equal to 0, and the second x is equal to 7 over 2, which confirms my two intersection points. I knew that my first intersection point was 0, and my second intersection point now turns out to be the rational number 7 over 2. So we're ready to set up our calculus so we can find the area. So my integral is going to start at the intersection point of 0 and finish at 7/2. And then I just need to make sure that I've put the correct function first. So which one should I lead off with? The negative x squared, because it's the top one. It's the one that's concave down. So I'll be leading off with negative x squared plus 4x plus 2 minus, and I have to subtract the terms of the lower. And again, here's where it's not the calculus that'll mess people up, it's the basic algebra. And when you subtract something, you got to be careful that you subtract the terms appropriately. So you'll be subtracting x squared, but adding 3x and subtracting 2, because that negative affects every term of the function that you're subtracting. And then without my calculator, I should be able to simplify this and now I'm ready to do the calculus. So I'll end up with negative 2x squared plus 7x, and the plus 2 and the minus 2 cancel out. So now I'm ready to do the antiderivative. So negative 2/3 x to the third plus 7/2 x to the second plus the constant c evaluated from 0 to 7/2. And don't worry, the math will turn out fine, even though you're looking at it, you're going, ooh, there's fractions. It really turns out to be okay. We've got negative 2/3 times the fraction 7/2 cubed plus 7/2 times the fraction 7/2 squared. And so what's 7/2 times 7/2 squared? What's a better way to write that? 7/2 cubed. It's better to write it as 7/2 cubed. So I'm going to just simplify this and write it as 7/2 cubed. And then plus c and then minus 2/3 times 0, minus 7, plus 7/2 times 0 minus c. So gone, 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 gone. And so even though you're using fractions, you still have negative 2/3 of the quantity 7/2 cubed plus a whole quantity of 7/2 cubed. So how many 7/2 cubed things do you have altogether? If you've got negative 2/3 as the coefficient of one of them and 1 as the coefficient of the other.
1/3.
Yeah, 1/3. So that really doesn't turn out to be that bad. And that's the answer. I mean, you could simplify that and you could, you know, say, oh, well, oh, yeah. No, why would there be a negative? Plus 1. Remember, this has a coefficient of 1. So there are negative 2/3 of the first one plus 1 of the second one, which is a total of, if you want to switch the order, if you'd rather have it, the positive one be first. But yeah, so then you could just leave it just like that. If you wanted to simplify it a little bit further, you would need to know what 7/3 is and 2 cubed. So that's 3 times 8 and 7/3, 49 times 3, 7. What do I get? 3. 7. 327? No, that's 3 to the, oh, whatever 7 cubed is. Yeah, it has to end in a 3. Yeah. So 243 over 24. 343 over 24. Either way, it doesn't reduce because 7, 2, and 3 don't reduce. But I'm fine if you leave it like this without your calculator. All right, any questions about that? Okay, let's do it with your calculator now. So grab your calculator out. All right, so you want to evaluate the area between y equals cos x, so make sure you're in radian mode, please, and y equals e to the negative x, and that would be on the interval 0 to 2 pi. Now, before you graph it on the graphing calculator, think about it, what you expect the graph to look like. All right, 0 to 2 pi of cosine. All right, so we should expect that cosine looks like this, with a y-intercept of 1, because that's where cosine starts. We're going out to 2 pi, and we're starting at 0. And then we expect e to the negative x. Well, you can imagine what e to the positive x looks like, and it goes through the y-intercept of 1, but e to the negative x is a reflection. So we know that e to the negative x should come down here and hit 1, and then it's going to scoot under, over, and under. That's what we should expect to see as e to the negative x comes through. So we're going to have a region of area to find, and then if we got to find an intersection spot, and then another area section to find here, and then another intersection spot, and then another intersection here. So that's what we expect to see. So we're going to grab our calculators and double check what these intersection places are. And so again, it's almost before you use your calculator to sort of think through how this is going to go. We're going to set up an integral that goes from 0, and let's call it a. All right, let's call our first green dot a, because we don't know what it is, but we know it's going to go to 0 and start at a. And we know the order of that would have cosine first, because cosine is above, minus e to the negative x. So that's going to be the first section. The next one, if we call the second intersection point B, it's going to go from A to B, and the order is going to switch, and now e to the negative x would be first, and cosine would be second. And then our third would start where the b picked up and end at 2 pi, and we'd be back to the original order of cosine first, and then minus e to the negative x. So I'm going to show you how to utilize your calculator to do pretty much all of that for you. All right, so go ahead and put those functions into your y equals and y1 and 2. Make sure you're in radian mode and set your window to be 0 to 2 pi. Okay, I'm in parametric mode, sorry. Alright, so we've got cos x, and we've got e to the negative x. And I'm going to set my mode, radian, yes, window, 0 to 2 pi. And I'll do pi fourths as my scale, I guess. And then my y min, I know it's not going to be higher than 1. I know it's not going to be, it's going to be above, not going to be any lower than -1, so I can go from -1 to +1, and that should be fine. Okay, and then we see the graph doing kind of what we expected it to do. All right, so we got to find what that intersection spot is, or the two intersection spots of this graph. Is anybody having trouble with this so far? Okay, remember how to do intersection? Second trace. Intersection is option number 5. Using your left and right hand arrows to sit yourself on top of the intersection point that you're looking for. They'll ask you for the first curve position, and kind of sit as close to that intersection spot as you can. Confirm your second curve position. Confirm the calculator's best guess. Okay, and then it should give you the first intersection spot. Okay, so I'm going to pause and wait here. I don't want you to go any farther than this because I want to show you how to store that into the memory of your calculator because you'll need it for later. All right, so from here, I want you to clear and go to your home screen. That number that the calculator just calculated, we would like the calculator to remember that for us. And so this has a storage feature, so see store right above on. All right, so as long as you're on a clear home screen, hit store. And we named that point what letter on our graph picture? A. All right, so use your alpha key and tell it to remember it as A. And then hit enter. And that should be the number that it just did. It will remember the last thing it did. Okay, so now it will permanently remember that as A forever until you tell it differently. All right, let's go back to our graph and let's find the other one. I'll pause a minute. And then we're ready to name the answer. Okay, so I got, and I hope you did too, 3.456 as the area. Is anybody not getting that? You would get full points for this with the exception of somewhere you have to write down what A stood for and what B stood for. So somewhere you would note that A was, I forget, I don't even remember, I can check. I don't know if it's A. 1.297 ... and B was 4.722. So all you have to write down is what the values of the intersection points were, write your full integral, and then hit go, and the calculator will do the rest. So there's very little work to show, but it is part of the rubric scoring points. You know, if this was a 3-point question and all you listed was the final answer without writing the other stuff, you'd still only, even if you get it right, you only get 1 point out of the 3 because you didn't write your integral and you didn't write your intersection points. So that's all I need to see for the calculator parts. So I'm just going to give you a chance to work for the rest of the period.